So if we want to see if we can find a pattern, which there is definitely a pattern in this, we'd like to find that because it'll simplify our work just slightly. We won't have to write out every single month. We can look at, here we have the number of youths plus the number of adults. If we look at it that way, here we have 1 plus 0 is 1. For this month, we have 0 youths plus 1 adult gives us 1. The next month, we have 1 youth plus 1 adult. The next month, 1 youth plus 2 adults. The next month, 2 youths plus 3 adults. The next month, we have 3 youths plus 5 adults. And if you're looking for a pattern, I don't know if you see it yet, but let's try another month and see what we get. If we have this adult pair, they're going to have themselves plus a youth pair. This youth is going to become adult. This adult will have adult plus youth. This adult will have adult plus youth. This youth will become adult. Adult plus youth, become adult, and adult plus youth. So now in this month, we have 1, 2, 3, 4, 5, 6, 7, 8 adults. And we have 1, 2, 3, 4, 5 youths. And as I'm looking here, that'll give me 13. As I'm looking here, I can see that I have 2 plus 3 is 5, and then 3 plus 5, which is maybe here, 3 plus 5 is 8, and then eight plus 5 is 13. So I see, let's see if it goes backwards too. So this one I have the 2 here, and then the 2 there, and here I have the 3 from the previous one. Here I have the 1. And so it looks like every month I'm taking the previous 2 months and adding them. So if I add up 5 plus 8, I get 13. If I add up 3 plus 5, I get 8. So let's try that out. This one we'll call F sub 1. That little number down to the right is a subscript, and we call it sub that number. So it's F sub 1, and that way I can keep using F for all of them, and I just increase my subscript. So the next one will be F sub 2, F sub 3, F sub 4, F sub 5, F sub 6, F sub 7, and then I can fill in the rest without having to draw my chart. Unless you really want to draw the chart, that's fine. But I can, for my next month, I can just add 8 plus 13, so I get 21. 21 plus 13 now, and I'll get 34. 34 plus 21 now, and I get 55. 55 plus 34 is 89. And I can fill in the F subs as well, so that's F sub 8, F sub 9, F sub 10, F sub 11, I'm almost done, F sub 12. So add these last two together, so 9 plus 5 is 14, 8 and 5 is 13, plus 1 is 14. So 144 is what I'm going to say for the result. In 1 year, you will have 144 rabbit pairs. And so these numbers that we just have been exploring are called Fibonacci numbers. Each number in the sequence is called a Fibonacci number. And the sequence is found by adding the previous two. to get the current. Okay, and that's our rule as well, that we add the two previous numbers to get the current number. So I could put that down there instead. That's probably better. And then we have also we have a formula that helps us find a particular number. So if we don't want to list out all the way from 1 up and up and up to the number that we want, say 35, we do have a formula which we could use. And it looks like this. And say, or use f sub n, and that means whichever sequence entry you want, whichever Fibonacci number you want, we would put that in for the big N there. We'll take 1 divided by the square root of 5, and then multiply by, here's the first term, 1 plus the square root of 5 over 2 raised to the nth power minus 1 minus the square root of 5 over 2 raised to the nth power. So if I look at this equation and I use the order of operations, I can tell I have to work inside these big square brackets first, and then I'll want to find the value of 1 plus the square root of 5 divided by 2, and then raise it to the n, which is whichever Fibonacci number I'm after, so say 35, so I would say 1 plus the square root of 5 divided by 2, and then raised to the 35th power, and then I would maybe store that on my calculator, and then on the second one, 1 minus the square root of 5 divided by 2, I would calculate that, raise it to the nth power, and our example was to the 35th power, and then I would maybe store that, and then take that first one minus the second one, that'll give me another number, and then this part here just means divide by the square root of 5. So then I would do that last. It says 1 over the square root of 5 times, and you could do it that way as well, but really you're just needing to divide that whole result in the big square brackets by the square root of 5. Okay. So the Fibonacci sequence is an example of a recursive rule because you need the values for the previous 2 terms to calculate the current. Okay, and so using that, we can find some of the Fibonacci numbers. This one says find f sub 10. That means the 10th element in the sequence, the Fibonacci sequence. So all I have to do is go back to this page where we wrote them all out, and I can see that my f sub 10 is 55. So that's the answer I'm looking for on this problem. So I can say equals 55. Now this problem here says f sub 10 plus 2. Notice that the 2 is not down in the subscript with the 10, it's up on the same level as the f. So what it means is find f sub 10 first and then add 2 to it. Well, I know f sub 10 because I just found it, so I have 55 plus 2, and that's going to give me 57. Okay. And this next one is f sub 10 plus 2, and you can see that the 10 and the 2 are both in the subscript, so it means do f sub, and then you have to do 10 plus 2 first, which is going to give me f sub 12, and then I'll have to go back and look or remember what I got for that one, but that would be this last one here, the 144. So f sub 12 is 144, and that's my solution for that part. Now I have f sub 10 and then divide by 2 because the 2 is big, so we do f sub 10 first and then divide by the 2 that's showing there. So my f sub 10 was the 55. Had to double check. 55 divided by 2, and you could actually divide that by 2 and write your answer as a decimal. That's fine. It'd be 27.5. And there's that. The next one, f sub 10 divided by 2. This time, look at between C and D. This time, or D and E, this time the subscript has the division in it. So we're doing f of 10 divided by 2. So I have to do 10 divided by 2 first. And that gives me f sub 5. And then I can go back to my chart and look, f sub 5 is 5. Come back to this page, and my result then is 5. Let's look at another one. Here I'm given 2 of the Fibonacci numbers in sequence, f sub 36 and f sub 37, and I have values for both of those. I could calculate using my formula to see if it works out, or I could just count up and keep adding to see if these are exactly what f sub 36 are and f sub 37, or I could just take them and agree that those are correct. So I want to know f sub 38, and to get f sub 38 I have to take f sub 36 plus f sub 37, because that's the definition of each Fibonacci number. It's the sum of the 2 previous Fibonacci numbers. So if I take those two, then I have 14, 930, 352 plus 24, 157, 817. And when I add those two together, you can do that on your calculator or do that by hand, you should get 39,088,169. And that would be f sub 38. So now I'm being asked to find f sub 35, and I don't know the 2 previous numbers to f sub 35, but I do know the ones after it. So what I can do is say, well, that's going to be the larger one minus the one that we just had, which before that, f sub 36, and that should give me f sub 35, because I know that if I have f sub 35 plus f sub 36, I will get f sub 37, and if I'm trying to find the f sub 35, I can just subtract the f sub 36 from both sides, and then I'll get f sub 35 equals f sub 37 minus f sub 36, and that's exactly what I'm trying to find. So when I do that, I have 24, 157, 817 minus 14, 930,352, and then I end up f sub 35 equals 9,227,465. Imagine if bunnies really did reproduce that quickly. We would have, in 35 months, that would be about 3 years, we would have 9 million rabbits. It's a lot of rabbits. Okay, I do want to show you this using the formula as well, just so that you've at least seen it one time. I could find f sub 38, for example, which was our part A, by taking 1 divided by the square root of 5 times big square brackets 1 plus square root of 5 over 2 raised to the 38th minus 1 minus the square root of 5 over 2 raised to the 38th, and then the ending square brackets. So then with my calculator, I'm going to first, this is the calculator that I have, I'm going to first clear, of course, and then take 5 and do the square root of it. And your calculator, you might have to do square root and then the 5, but mine is backwards. So 5 and then the square root, I get 2.23606, and it goes on. And then I want to add 1 to that, so I'm working on this part here first. So plus 1, and then I push equals because I don't trust the calculator's order of operations, and neither should you. And then that gives me 3.23606 and so on. So it's 3.23606 and so on. Have to divide that by 2. So divide by 2 equals, let's see if I get a little more space here, and then I have 1.618 raised to the 38th power. So then I will do 2 to the 38th equals, and I get a very big number, 87403,803. And with that number, I want to store it. So again, on my calculator, I push store and then 1. You may have store and then move over to A, B, or C and so forth. But I'm going to put that in 1. And so I'll just put a little circle to remind myself where I stored it. And then I need to come back and start again on this next part. So I'll start with the square root of 5. So I type in 5 first, do the square root of it, and I still get 2.236 and so on. And then I'm going to change the sign on that to negative and then add a 1 to it. And at this point I have negative 1.23606 on and on divided by 2. Quantity will be raised to the 38th power. And then my next step is to divide by 2. And it is a negative 0.618 and on, but I have to raise it to the 38th power. So then now I say 2 to the 38th equals, and I have 0.00000, several zeros, and finally a couple of 1s. And I'm going to store that in my second bin, or bin 2, so I'll just write that down. And then now I need to do that subtraction because that's inside my big square brackets. And I have to do 1 times the square root of 5, 1 over the square root of 5 times that when I'm done. So I'll take that subtraction. So to do that, I recall 1, and that gives me the 87,403,803. And then subtract, recall 2, and that gives me the 0.000011. And then equals. And so now I have, I'll come up here, I have 1 over square root of 5 times, I have 87,403,803. Pretty much looks like that number we started with, because that 0.0001 is just in the noise. It's barely going to affect us, and it definitely won't show up on the calculator. And then remember I said we can just divide by the square root of 5. So I'm going to do that. I'm pushing divide, and then I want to use parentheses and do square root of 5 like that, just to be safe. So I'll do that, and then I do 5 square root, and I see the 2.23606 and so on. Push my right parenthesis and then push equals, and then that's how I entered it on the calculator. And then my F sub 38 is going to give me 39088,169. And let's double check that from above. F sub 38, 39088,169. So that procedure will work if you want to find a Fibonacci number and you don't know the previous 2 or the following 2. Then you can use that formula, but it's much easier to just add or subtract the 2 previous or the 2 following, depending. So there it is, so you can see the formula at least once.